Okay, Mo and Joe both have identical watches. Joe is moving with respect to Mo at 0.85C. So Joe is the moving clock, Mo is sitting still. If 15 seconds elapse on Mo's clock, how much time has elapsed on Joe's clock? Well, this is a complicated thing. But basically we can think this through, right? If Joe is moving, his clock is slower. Time is traveling slower in his frame of reference. So we're not asking how long it takes Joe's clock to show 15 seconds of elapsed time. We're saying in 15 seconds of our time, how much time is on Joe's clock? Well, if his clock is ticking slower, therefore there's going to be less time registered on his clock. Right? So this is kind of like asking the question in an opposite fashion, right? So the way we do this is we just take the 15 seconds. It's going to be less time, right? So we go 15 seconds, and we just multiply by that factor then, okay? Because I know that'll give me less time. Now, it's far easier to do this and think it through this way than to try to like figure out proper time and all of this. No. If its clock is running slower, it's going to be less time. Use this factor to figure out how much less time. Okay, so let's figure this out. So it's just going to be 0.85 squared, right? Because the c's cancel out. It's 1 minus v squared over c squared, right? But this is what we do. So we go 15 times the square root of 1 minus 0.85 squared, and I get 7.9. Which presumably is what it says under all these little toolbars or something like that, 7.9 seconds. Okay, because his clock, this is the moving clock, is moving, the time is traveling slower in that frame of reference, so therefore it shows less time elapsed.